Hello, I am Ilham Muhammad. Today we want to discuss about scoping sets and tracking sets. In your mind, what do these terms mean? These terms are defined in coding theory. One of the most important types of codes are called LDPC codes. That means low density parity check code. A low-density parity check code is a linear error-correcting code, a method of transmitting a message over a noisy transmission channel. LDPC codes are used in many applications. However, these error-correcting capabilities are limited by the presence of scoping sets and tracking sets. Tracking sets and scoping sets occur when specific low-way error patterns cause a decoder to fail. In this lesson, we don't want to talk about the nature of scoping and tracking sets. Also, we want to explain about graphical form of this. Okay, in the first step, let's go to the definition of a Tanner graph. In coding theory, Tanner graph is a departed graph used to state constraints or equations which specify error-correcting codes. In coding theory, Tanner graphs are used to construct longer codes from smaller ones. Both encoders and decoders encode these graphs extensively. Tanner graphs are partitioned into subcode nodes and digit nodes. For linear block codes, the subcodes denote rows of the parity check matrix, and the digit nodes represent the columns of the matrix edge. An edge connects a subcode node to a digit node if a non-zero entry exists in the intersection of the corresponding row and column. For example, suppose that this parity check matrix is given and we want to draw its Tanner graph representation. Notice that the subcode and digit nodes also have other names as check nodes and variable nodes respectively. In this parity check matrix you see some 1 and 0. The rows are corresponding to the check nodes and the columns are corresponding to the variable nodes. An edge connects a subcode node to a digit node if a non-zero entry exists in the intersection of corresponding row and column. For example, the entry of the first row and first column is 1, so there is an edge between V1 and C1 vertex. But the entry of the first row and second column is 0, so there is no edge between V2 and C1. In the same way, we specify the other elements. The advantage of this technique is that it is computationally tractable. Now, let's go to define a scoping set. Scoping sets are collections of variable and check nodes in the Tanner graph of an LDPC code which greatly reduce its error-correcting ability. These sets cause decoding to fail when certain variable nodes are affected by errors after transmission. These sets define as follows. Let G be a Tanner graph and V be the set of variable nodes in G. A scoping set S is a subset of V such that all neighbors of S are connected to S at least once. The empty set is also a scoping set, and the space of a scoping set is closed under union. It means if S1 and S2 are both scoping sets, then so is S1 in unity S2. For example, In this shape, the sets of V1, V2, V3, and V4 are stopping sets because all neighbors of S are connected to S at least twice. Trapping sets, much like stopping sets, are also a collection of variable nodes and check nodes which impede error correcting ability of a DBC code. Let G be a Tanner graph for a received vector Y of length n. We define the failure set Ty to be the set of bits that are not eventually correct using some arbitrary iterative decoder. Decoding is successful on Y if and only if Ty is not equal to null set. So trapping set is defined as follows. If Ty is not equal to null set, then Ty is the trapping set. More specifically, T is an A and B trapping set if it has a variable nodes for which the subgraph induced by T contains B more than 0 odd-degree check nodes. For example, in this shape, V1, V2, V3, and V4 is a trapping set. Goodbye.